Today's episode of the Energy Question podcast is brought to you by Enverus. The energy industry faces challenges every day, and the events of the last 2 years have caused massive disruptions like never before. Companies in the energy industry need actionable intelligence and a single source of truth that brings all the data together. Enverus is the energy specialized technology partner that provides intelligent connections for a global energy ecosystem. Only Enverus has the analytics, people, experience, and industry scope to connect the right data and information in the right way to discover missed opportunities and deliver fast outcomes. Find out more at Enverus.com. That's ENVERUS.com.
Hey, welcome to the Energy Question with David Blackmon. I'm your host, David Blackmon, and with me today is Craig Jones, the CEO of Forever Energy, a company with an innovative new battery technology that hopefully is going to play a very key role going forward in the energy transition. Craig, thank you for joining me.
Thank you for having me.
Hey, where's your company based right now?
So we were in Seattle, but we're in the middle of a transition to Dallas because of a partnership with power controls company Solarc, which is based here in Dallas.
Oh, okay. So let's talk about Vanadium Flow Batteries, this technology innovation that your company is playing a central role in here in the United States. Talk a little bit about what Vanadium Flow Batteries are and what compelled you to start the company.
So vanadium flow batteries have been around for decades. The innovation actually emanated out of Sydney, Australia. A Greek professor discovered the technology. And these are single acid vanadium. So there's basically two types. It's the electrolyte, the chemical that goes in the battery, simply is vanadium, which is a metal, sulfuric acid, and water. And that's the major portion of the battery. Our innovation, which emanates from the United States government national lab system, specifically Pacific Northwest National Lab, that they patented around the world in 2010 timeframe, is adding hydrochloric acid to that mixture. So our battery innovation is vanadium, so a little bit of sulfuric acid, and hydrochloric acid. And the hydrochloric acid, from our standpoint, well, there's no doubt that it's double the energy density and that it's also much more temperature resilient, both on the high temperature and the low temperature.
So I had a recent interview with a lady named Bernadette Johnson, who's an executive at Enverus, a big energy analytics firm based in Texas as well. And she was, we had a wide ranging discussion about the energy transition. She was very specific that we're going to have some real step change innovations in battery technology for the energy transition to succeed. That's your belief as well, correct?
Absolutely.
Yeah. And so how many vanadium flow batteries have existed, as you said, for quite some time, but how many manufacturers of this technology exist currently in the United States?
Well, there's the domicile of one company called CellCube. They're in Austria, but they've just announced that they are opening a manufacturing plant in Colorado.
Oh.
There's a London listed but Canadian Chinese backed company in Vancouver, Canada, called Infinity. These are the two biggest players in the single acid space. There are no players in the United States on the mixed acid space. And vanadium is a very minutely processed material in the United States as well.
So talk a little bit about, where vanadium exists, first of all, the medium it's in, and then also how it's recovered and produced.
Yeah, so vanadium is actually not rare. This is a misnomer. It's twice zinc in the Earth's crust. So it's actually everywhere. You have huge deposits in South Africa, Australia, Quebec. There is back in Henry Ford's day, the Ozark Mountains in Arkansas, all around Hot Springs to Little Rock. That's a huge area for vanadium. And actually today, they even process vanadium waste material. So vanadium is not rare, and it is everywhere, except that its use case is very limited. So the 99% use case of vanadium today is hardening of metals, of steel. In China, so all rebar will have some sprinkling of vanadium in it to harden. But also it's used in all sorts of alloys and things like that because it's a steel hardener. That's what Henry Ford did 100-something years ago. But really, its big value for the future is in these vanadium flow batteries.
Yeah, and talk a little bit about that. You know, as we record this, we're having a big heat wave in California, and you know, California has invested billions and billions of dollars in recent years in backup batteries for wind and solar power there, stationary battery installations. Talk about the problems with the current technology that's used in those big battery installations.
Well, I mean, right now, the market for batteries for storage is lithium, various lithium chemistries. And the lithium battery is in your phones, your consumer electronics, your automobile, and many people want it to be the stationary storage standard as well. We believe that, and frankly, the Chinese have already pivoted to other such as vanadium flow as the stationary storage standard. So we're very focused at Forever Energy on stationary storage applications.
Yeah. So, you know, electric vehicles, of course, is the other piece that's been highly promoted for the energy transition, and they, you know, have continued to use lithium-ion batteries technology for the most part. Does vanadium, do these vanadium flow batteries have any application in the transportation space as well?
Well, no, not our vanadium flow battery, and all vanadium flow batteries are mechanical devices. And so really their application is for stationary storage.
Gotcha. So what, you know, here in the United States, what has been standing in the way of accelerating production of this kind of battery here domestically?
Well, I would say that the number one issue is capital markets. And I think Elon Musk says this well: if you want stuff, you got to make stuff. And capital markets, just the way and you know, you can't fault, it's human nature. They want the easiest path to high returns.
Sure.
And that in the past has been software orientated. And I think, you know, Wall Street is like other institutions or organizations. They like to look backward. And we think that they're looking, for instance, at the computer revolution model, where the software companies were the winners and the hardware companies kind of weren't. We believe that the new energy revolution, that there's going, because Forever Energy is both a hardware and a software company. We actually imagine that the vast majority of our revenues in the future will be generated from the software that's embedded within our battery, and helping customers who own our storage manage the discharge of that energy out of that storage device. But you know, this is the issue: is that capital markets need to understand, and Washington needs, and they are. These two, love them or hate them, Biden's two initiatives, the BIL adopted in November and the most recent Inflation Reduction Act, these are massive legislative initiatives. The IRA, for instance, we could do a whole show on that. This is profound.
Well, that was actually my next question. You know, it's, you know, we talk about capital markets, but I just wonder, is there any provisions in either of those big bills you just referenced that would provide any kind of startup funding for this kind of technology?
Yes.
Venture?
So Forever Energy via BIL, Department of Energy has billions of dollars of grant monies that are starting to come through the pipe.
Okay.
And Forever Energy is actually in application for grants through Department of Energy. That's through the BIL. And then on the IRA that was just approved, there are advanced manufacturing credits that give, and these are transferable tax credits that we could sell and use as a security to help us raise capital. But these subsidies of manufacturing in the United States are massive. They are a great, we're now introducing capital markets to this legislation and how profound it is. And frankly, it gives us, there's debt, there's equity, and now there's these tax credits available to us on both the power controls and on the battery that are going to really, for Vanadium Flow, actually allow us to leapfrog lithium, which of course is vastly based offshore.
Right, right. So yeah, and I've written a lot about that, and of course, let's talk about supply chains for a minute. I think it's pretty well known at this point that supply chains for lithium, particularly the mined lithium in Australia and other countries, pretty much all flows through China. And these supply chains, and it's not just lithium, it's a lot of other minerals that are really integral to the energy transition. What about vanadium? Do the supply chains currently for vanadium tend to flow through China?
Well, okay. So what's interesting about that is, so China has vanadium just like other countries and continents have vanadium. It's not rare. And they're mining it a lot in the Sichuan area because they have, I forget what the quantum is, but, China has many times more steel manufacturing than the whole world combined, right?
Right.
So they mine, and vanadium's 99% use case today is primarily in steel hardening. So they have a very large scale vanadium industry already, but it supplies mainly the steel industry. However, they have already, years ago, Beijing has already invested tens of billions of dollars, and nearly every province in China has a vanadium flow battery initiative within the province, and there are more than 100 vanadium flow battery factories in China.
Wow.
So within China itself, and oh, by the way, Beijing has now banned the export of vanadium. So within China, there is a very robust vanadium supply chain.
Wow.
Around the rest of the world, it is nascent. So I cited zinc, that vanadium is twice zinc in the Earth's crust, but every year, 12 million tons of zinc are processed via ore, primarily, around the world, compared to only 100,000 tons of vanadium. So the supply chain is just totally nascent. And that's why one of our big initiatives at Forever Energy is we have a subsidiary called Vext Energy, and we propose to do a processing plant in Shreveport, in the Caddo-Bossier port, where we would bring in waste streams from the United States, but also from around the world, because there is all sorts of industrial waste, fly ash from oil refining, for instance, that in some applications is laden with vanadium. So interestingly, the entire Orinoco Plateau there in Venezuela, all of that oil, in fact, most oil that's that thick, sulfury crude is laced with vanadium. So it's everywhere.
Wow. So let's talk about, you mentioned the production facility you want to do in Louisiana. What's the draw to the state of Louisiana that makes it an ideal location?
So Louisiana offers, and North Louisiana in particular, offers a lot of benefits. So, this vanadium processing plant that we're talking about, so we can produce 80 million pounds of vanadium per year, which we need for our batteries. We need river access because that's bringing in
Yeah.
waste streams from all around. So logistically, that makes a lot of sense, right? So you
So
land
the Red River road flows right through Shreveport, right? Yeah.
exactly. So you land the base material in New Orleans, take it up to Mississippi, go west on the Red River, and you're right there. It's terrific. So from river access on the vanadium extraction, it's really great. Shreveport also, that whole North Louisiana has fantastic rail access because our batteries are heavy. They're 80% water by weight. And so we would be transporting final product often by rail. So there's great rail access, great logistics, great roads. And frankly, North Louisiana is not booming. Real estate prices are reasonable. There's available facilities. There's a ready, willing, and able workforce. Government, we've enjoyed fantastic support from Governor Edwards and others. And so we're really looking forward. We haven't cut our final deal yet, but we really believe that North Louisiana is great area. But quite frankly, given there's a lot of other states also that have been soliciting us and wanting to talk to us because we do represent the base industrial of this new energy transition that is happening. And vanadium flow, as I said, China is creating this standard. And the US has we would be the first large scale factory at scale. And as I said before, the Chinese already have 100. I think it's very important that the United States get involved in the vanadium flow battery manufacturing and the entire supply chain.
So what's going to happen? What are the next steps to making this plant in Louisiana a reality?
Yeah, I mean, we need to finalize negotiations with the state. We need capital, both debt, equity, and now with these advanced manufacturing credits from the IRA law, we can use those. We need to raise that capital and get going on that. We're waiting to hear about the grants from the DOE. So we're in that process now.
Well, talk about the grants from the DOE. What's involved in getting those in place?
So the public process, they do a funding opportunity announcement. They make it known that they have these funds available. And then you go through an application process, which we're in the middle of now.
Is there do they have to, are you going to have for this plant, people complain about how slow it is to get a permit out of the federal government right now for any kind of energy installation? You're going to have like air permits from the EPA and those kinds of things as well?
Yes, and that's another advantage of North Louisiana. Louisiana in general is that it already has existing processes through the hydrocarbon economy that's there. So also permitting and what have you is more expedited. The process is known. You're not skipping any steps. It's just the bureaucracy there understands how to process because they do it all the time, because Louisiana has a lot of chemical factories. Because our chain is we literally will be able to produce that battery soup to nuts with zero foreign supply chain. We'll be able to do it right there in Louisiana.
Fantastic. And that brings me back. I want to go back to supply chains for a second, because I asked this of everyone I interview just about. About a year ago, the Biden administration announced that they were going to mount a whole of government process, a big project internally within the administration to really speed up the process of onshoring supply chains for these very minerals that are critical to the energy transition. And I wonder, I asked this of so many people, and no one can really tell me specific actions they've seen the Biden administration take in that regard. And we're a year later, and I'm just not seeing any real tangible results. Is there anything you can point me to that shows they're actually mounting that whole of government effort?
Yeah, there is.
Okay, good.
Department of Energy. So we are in contact with Department of Energy officials in various different, the LPO program, the grant programs. So there is no doubt that the Department of Energy specifically understands the importance of vanadium. Department of Energy and Department of Defense classify vanadium as a strategic metal. And so it's really then up to companies like Forever Energy to come to them and say, hey, there is vanadium in the mountains of Nevada, which there is. And so, you know, that mine needs to be, the permits need to be pulled, and it needs to start to be processing. The problem is supply chains are like riding a bike, right? Once they get going, they've got the momentum and everything's wonderful. The problem is getting them started.
Yeah.
It is difficult because it requires real capital, real logistics, and real extra effort and energy to get that thing moving. Once you do, though, it can become a juggernaut. And we believe, and that's why we're lobbying Washington hard and wanting to do shows like yours to show the public, educate the public on the importance of vanadium. But vanadium, you know, is fully renewable, so it lasts forever. You put it in our electrolyte lasts forever. So it's not like the fossil fuel where you burn it and it's gone,
Right.
and you got to go find more. You mine this vanadium out of the mine. It's just like that watch or that ring you have. It lasts forever. Our vanadium electrolyte will last forever.
Do you feel like policymakers in Washington, not just in Washington, but really at the state level too, really understand that to make this all work, we're actually going to have to get back into the hard rock mining business in the United States, and not just a little bit, but in a really big way. And I just wonder if the people who control the permitting processes and the policy or legislation in Congress really do truly understand that renewable energy means a lot of hard rock mining, and you know, that's a controversial thing in the United States.
Yeah, no, policymakers are not aware, but quite frankly, that's my job. My job is to educate the policymakers because I'm the CEO of the company that makes that product. So it's my job to educate them and get them to understand. And that's why I'm doing your show and going to Washington often and taking meetings to educate people, because you're exactly right. People have to understand solar panels are fantastic. They are a very low cost, reliable, non-polluting form of generating electricity. But when the sun goes down, you got a problem. You need storage, right? And so there's various different types. Our vanadium battery absorbs all of that solar generated electricity beautifully. This is a beautiful combination, but to have a vanadium flow battery, I need a lot of vanadium.
Yeah.
And so exactly what you're saying is right. We need in the United States, and we should not rely on foreign countries for this supply. There are domestic supplies. But by the way, we could do a whole show on Australia, because somebody is going to buy Australia's vanadium. Right now, the Chinese buy almost all of Australia's iron ore. And I believe it's very important strategically that the United States get in there and buy and secure all of that Australian vanadium and start looking at vanadium as DOE and DOD call it a strategic material, and start recognizing that the sources in the US and sources around the world need to start to be secured. This is going to be a very important metal for the future.
So let's talk timelines. That's critically important as well if we're going to meet these targets that are all the governments and companies are setting. Let's assume you can get your negotiations successfully completed with Louisiana, your grants and other funding in place, and permits in place. How quickly then would you be able to get this factory up and running in Louisiana?
If we can get the facilities we want, we could get it done in about a year and a half.
Wow.
And that would be scale production.
Yeah.
Yeah. Because our battery is a plastic and water battery. So we're basically taking the polymer beads that in Southeast Texas and South Louisiana they make that come out of the oil refining. And we take those beads, we melt them, we form them into tanks and secondary containment and plumbing. And that's our dry system. And then our electrolyte is 80% water by weight. And like I said before, a little bit of sulfuric, hydrochloric acid, and vanadium. So we can get this factory up and running at scale if we are able to raise the capital. And we need Washington's help on that. And they are helping us. That IRA gives us a new tool, but we could do this very quickly. And we believe, example, so under the IRA, now customers can now get a significant tax credit of 30%, possibly even up to 50%, depending upon how you file, from the buying of storage only. There are millions of Californians who have rooftop solar, but have no storage. And in the past, they've been able to sell back to the grid that rooftop solar generated electricity and get equal to what they pay. But now, under various different regulatory regimes, that process is called net metering. That net metering rate that you send that solar electricity at noon is going down dramatically. At the same time, between 5 and 8 p.m., time of use rates, Southern California, Edison, for example, in summertime, is charging 65 cents a kilowatt hour between 5 and 8. To give you a sense, in the Pacific Northwest, the rates are
holy cow, that's incredible.
Yes. And so that's why storage is so desperately needed. So there's 2 million Californian homeowners who are desperate for full home backup energy storage for their solar systems so they can escape those really incredibly high time of use rates.
Right.
And they already have the solar on their roof.
So we actually scoped that out at our home here in Texas after the big freeze last year, and found that the actual battery, the lithium-ion batteries that currently serve as the backup technology for home solar, are really expensive and they don't last all that long. And if, with the vanadium batteries, would they be less expensive? Would they last longer? Talk about that aspect of it.
Yes. So when we manufacture this battery at scale, we can significantly manufacture it at a lower cost than lithium. So even the initial investment into the battery can be lower than lithium. Because in the lithium, the Wall Street Journal, other publications, they talk a lot about the cost of a cell and what that cost of the cell is. And the big number is $100. Can you get the lithium cell of various chemistries under $100? Companies supposedly like Tesla have already broken through the $100. But then the issue is that cell has to go into a pack. The pack is basically a cooling system, a refrigeration system for all those cells. That's then a totally different story. You're adding huge costs to all that cell to keep those lithium cells cool so they can operate.
Right.
We, on the total cost, we beat the lithium pack cost. So on that, and then we last 4 times as long because our electrolyte never degrades.
Yeah, that was the big killer for us. It was like about the time you start to break even, on the whole thing, selling the power back into the grid, you got to replace the batteries all of a sudden. And that's another, big expense. So anyway.
Yeah, that's the big advantage of vanadium.
Right.
Vanadium flow batteries, you can fully charge them. So there's you keep it at 80%, between 80 and 20. Everybody that drives an electric car will know this. You shouldn't charge your car over 80 normally, and you shouldn't go below 20. Vanadium flow batteries, on the other hand, fully charge them daily, fully discharge them daily. They want to be worked like that. You get the full range of the battery daily, and the electrolyte never degrades. Our pumps will wear out, but the pumps are a very small thing. After 7-8 years, we have to replace pumps for you. But the stack will last 30 years, the tanks, the electrolyte. And so, this is akin to your plumbing system in your house. It will last decades. And we think that's a very important part of the value of the vanadium flow battery and the mixed acid vanadium flow battery for property.
Yeah, that would be huge. I can't wait. I can't wait till you get that going. I'll have to reassess then. Listen, this has been a fascinating interview. I'm afraid we're out of time here. It's
Thank you for
really
inviting.
flown by. But yeah, let's plan to cycle back again in a few months, see where you are, and give everyone an update, because I think this is really a critical development here in this energy transition. So thank you again for being willing to do the show.
Thank you. Thank you very much for the invitation. It's a pleasure.
That is all today for this episode of The Energy Question with David Blackmon. Thank you for joining us, and we'll see you next time.